Good morning. Welcome to online lecture. This is G.V.Nagesh. In previous class, we have studied about the properties of nanomaterials, applications of nanomaterials, and the synthesis of nanomaterials by using sol gel method. Now, in this class, we study about a carbon nanotubes, which is a very important in nanomaterials. Here, this carbon nanotubes is a promising group of nanostructured materials, and these carbon nanotubes are a new form of carbon made by rolling of a graphite sheet in the form of a cylindrical, a long closed tubes. There are the two types of nanotubes, mainly single walled carbon nanotubes. It is denoted by CWNT, and multi-walled carbon nanotube MWNTs. This single walled nanotube consists of only a single graphite sheet with one atomic layer in thickness. Well, multi-walled nanotube is formed from two or more sheets. A thin graphite sheets are arranged concentrically into a tube structure. Now, here, see here, the different types of nanotubes. These three are known as single-walled nanotubes, and this is multi-walled nanotubes MWNT and SWNT. And this first one, the first figure indicates armchair. This indicates armchair, and these tubes are known as zigzag tubes, and this is known as chiral tube, and this is multi-walled tube. Now, in next slide, I show how these tubes are formed by using a single paper. Now see, let us consider this white paper as a graphene sheet. Okay, this is known as the single walled. Let us consider the single walled graphene sheet nanotube. Now we roll this tube, this paper. Now we observe a cylindrical tube. This is simply a cylindrical single walled nanotube. Let us consider if you take here a point O and this is point A. Okay, point O and point A. Okay. Now, if you twist this cylinder, this paper like this, again we observe a cylindrical tube. And here what happened? The O and A making some angle theta. Okay, this type of tubes, nanotubes, are known as chiral nanotubes. These are known as chiral nanotubes. Now, if you open this sheet, we observe some hexagonal shapes here. Here, in chiral nanotubes, we observe a different hexagonal shapes. Now, by using these hexagonal shapes, we can define armchair and zigzag method. In next slide, we can clearly show that armchair and zigzag method. If we use another paper, let us consider this is a graphene sheet, and this is also a graphene sheet. When these two sheets are combined together, and if you roll these two sheets, then we observe a multi-layer, multi-wall or similar, what are multi-layer or multi-wall nanotubes. If you use more than 2 graphene sheets, then it is said to be a multi-layer graphene sheets. And next slide we clearly identify what is the armature and zigzag method of zigzag shapes of this nanotube. Okay. Now, in this slide, see, when you reopen this paper, then we observe the hexagonal, if a sequence of hexagonal figures are present in this paper. Now, this, see, from this, see, from this diagram, here O2A, see, from this diagram, here from O2, this from this point O2 and this line A1. Here we observe a line. Here this figure shows armchair. This will be act as a armchair. That is a imaginary. This is not a clearly armchair. But if you sit here and these two are the arms of the chair. So this line, this dotted line indicates armchair nanotubes. And here from O to this point, if you draw a line here, then we observe this C. This line should act as a zigzag. So this is known as the zigzag nanotubes. From O to A, this is known as chiral nanotubes. These are the 3 types of nanotubes for single wall nanotubes. Now you take some properties of nanotubes. Here see the properties of nanotubes. Nanotubes are nothing but nanotubes are mechanically very strong and flexible compared to other metals. Nanotubes can be either electrical conductivity or semiconductor, and depending upon their facilities, it will be changes into different properties. This one-dimensional fiber exhibits electric conductivity as high as copper. Means this simply we are using graphite. The graphite is more conductivity compared to copper, and it is the highly thermal conductivity depending upon diamond as well as diamond. So it has, this graphite has this type of the high conductivity property as well as high electric conductivity, thermal conductivity and electric conductivity properties. And the strength is 100 times greater than the steel at 1/6 of weight, and it is high strain failures. The current length limits are about 1/1,000,000th of the second. Thank you.